record on this. So I'm recording now, you guys. So if you ask something, it'll be recorded. When I stop doing the problems, I will stop the recording and you can ask questions at the end, all right? So let's first go through the problems. I'm gonna go up to the my iPad. All right, these are on the sheet that I had there, the breakout room practice problems, okay? And like I said, section 2.1 produced this formula. I want you to be able to use it on the quiz tomorrow, okay? I'm gonna ask you, I'm gonna give you this formula and say use it to find what is the slope of the tangent line at x equals c. So at x equals 1 is what we're going to do here, okay? So the first thing is replace c with the 1. That means I need to put c1 here, 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 and here. So let's go through. I'm going to do this first problem now, okay? So I've got, we've got f prime of f prime. I said at x equal 1. So the c becomes 1 right there. Equals the limit as x goes to 1 of f of x minus f of 1 over x minus 1. Okay, so everybody notice, right now, if you take the number that the limit is going toward, you plug that in, the denominator is 0. So the goal of this, and every time it should happen, that lower x minus 1 should factor out of what's on top, okay? It's going to cancel out a factor up top. That's something you're looking for. So let's fill in what's going on here. So let's, first of all, we need f of 1. So let's see, I'm going to put f of 1 up here. Let's just figure, we need f of 1. So let's figure out what that is. That's just going to be plug 1 into x. So that's going to be 1 squared plus 4, which is 1 plus 4, which is 5. So the coordinate f of 1 equals 5. That means the point that we're hitting at on the graph is going to be 1, 5. That's the coordinate. Those are the coordinates that we're going to run into and be using for this function. So we got f of 1 equals 5. So this becomes equal to f of x. Now we put limit as x goes to 1. F of x is our original function, x squared plus 4. And what is our f of 1? F of 1 is 5. So we've got minus 5 over x minus 1. Do you see what's going to happen with the numerator? Difference of 2 squares coming, you see it? Okay, so what we've got on top now, notice I'm using equal signs, you guys. If you don't use equal signs where they belong, I'm going to start marking off on this last test, on the test, okay? So we've got the limit as x goes to 1 of x squared minus 1 over x minus 1. Factor the numerator, yeah? Yeah. Equals the limit as x goes to 1 of x plus 1, x minus 1 over x minus 1. I put parentheses around the denominator, you didn't have to, it's just sitting down there, but they cancel, it now cancels. Notice what that leaves us. I'm going to rewrite this. I'm going to show each step. You know, you can be more efficient when you're doing an assessment or something, but look at this. Now we've got the limit as x goes to 1 of x plus 1. There's no denominator. There is nothing being made equal to 0 in the denominator. So now we can plug 1 into the function. Therefore, this equals, I'm plugging 1 in, therefore LIM goes away. I'm plugging 1 in, so I'm not taking the limit anymore. This is the answer. So it equals 1 plus 1. No lim. I plugged in 1 for the x because that's what the limit was going to, and that equals 2. So remember what this is saying. We've got the slope of the tangent line at x equals 1. That's m. All right? Now, what I put over here on the side is, I'm going to ask you, possibly on the test or something downstream, write the equation of the line. Okay? We've got the slope at x equals 1. We've got the point at x equals 1. You should be able to write the equation of a line. And you should do it by either using y equals mx plus b. And that's what I'll do this first time. Y equals mx plus b. We've got, okay, so we've got the point is 1, 5. So y is 5, m is 2, x is 1. We don't know b. So if I subtract 2 from each side, I end up with b equals 5 minus 2, which is 3. So what's the equation of the line? Y, we got b, we got the slope equals 2. So y equals 2x plus 3. That's the equation of the line tangent to the graph at x equals 1. Now,
Hey,
I'm going to
Professor,
go ahead, ask, yeah.
quick question. Why did you subtract 2?
Y is the, say it again, you're muffled.
Why did you subtract 2?
Why did I subtract 2? Okay, we're solving for b here.
Right, but wouldn't you have to divide by 2?
Okay, so look here, I'm solving, this is b right here. So this is 5 equals 2 plus b.
Gotcha.
Okay,
Okay.
you saw that 2 as a multiple that we weren't, it's not a division type scenario. So it's just a matter of subtract 2 and you got it, okay? Good ask, good to clarify. Okay, so now watch you guys. We've got the function and we've got the tangent line. Draw it on, put it on Desmos. And if it doesn't work, then your answer's wrong. Check and see if your answer's right. So I'm gonna go to Desmos right now. And let's go to, let's see, we've got x squared plus 4. I'm going to get rid of this natural log. I'm going to use this function right here. Y equals x plus 4. Notice what that is, remember. This is y equals x squared moved up 4 places. So what does the graph look like? All right. So it's y equals x squared. Remember, y equals x squared is, if you're at 0, 0, over 1, up 1, over 1, up 1, over 2, up 4. Check it, your graph. Now you need to keep track of that. Over 1, up 1, over 2, up 4 is an important part of a standard parabola, okay? Over 1, up 1, over 2, up 4. But it's been moved up 4 places, all right? That's what we've got here. Now let's do the equation of the line. We've got y equals 2x plus 3. Boom. It touches at 1 point. 1, 5 is what we got. It matches. Check your work when you do this on an assessment. Verify it's right. Because if this didn't touch right there, something's wrong with what we did in the calculation, okay? So what we answered the question was, we were given a function and we were asked to find the slope of the tangent line at x equals 1. We got it and wrote the equation of the line. Boom, all right? Question?
I think you aren't showing like what you're looking at.
No, okay, I'm sorry about that. So I need to go back to Desmos. Yes? I'm sorry, you guys. Okay. So look, the original function was y equals x squared. Over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4, but it got moved up 4 places. And now when I plug in y equals, I didn't do y equals on this. Notice it's just 2x plus 3, and that was sufficient. I could have done y equals, and it would give me the same picture. But notice it touches. Thank you for speaking up, Peyton. Sorry about that, you guys. Notice it touches at 1, 5. Know your answer's right. We've got the slope of the graph, the line, and if it does not touch at that 1 point, you did something wrong. Something is wrong if it doesn't do that. Every time it should work, okay? So you use the tool. It's a fair game use of a calculator on assessment, okay? Check your work. Okay, so that is that. Any questions about that? Okay, and notice, like I said, I could have put y equals for both of them, but I didn't for either, and it worked out fine. if I put y equals, it would have given us the same exact situation. Notice it didn't change anything, okay? All right, so now let's go back to the problem sheet. Thank you for speaking up again about the, I'm gonna go back to the iPad. Okay, now, the second part. So, this is really kind of important because this up here, this original problem was asking for the slope at a point, okay? That gave us an equation of a line at that point. Now this, what we're moving into in 2.2, is we're just gonna take the derivative of the function. And it's gonna turn out like we got a parabola. Notice the slope is different at every point. That means at every point, an x is gonna show up in our answer, right? And x is gonna show up, it changes with whatever your value of x it is, all right? So we found it at one point. Oh yeah, I want to say this too about sapling. There's a couple of problems that ask you to find what is the derivative, what is the slope, what is the rate of change of, it's f of x equals 6x plus 1, let's say. It says 6x plus 1. Notice what that is, 6x plus 1. That's a line, right? What is the slope of 6x plus 1? Y equals 6, right? It's the slope is 6 for the entire graph. So when you take the derivative of 6x plus 1, y equals 6x plus 1, you get 6. It's always a number, that's it. Whereas it's always 6, but in this function we're dealing with right here, look at this one, the slope is different at whatever x you're at. The slope is going to change. So let's go down here to the problem. Remember, I'm down here at number 2. F prime of x. Remember, f of x plus h now. I'm going to use lim as x goes to h, excuse me, as h goes to 0, not x. Okay? And I'm going to use a smiley face to replace it for a couple things here, and that'll remind you you can do that. But the idea is, you guys notice that all the equal signs I have up in that top problem. All the equal signs, all the way through. All the way through. Some of you still aren't using equal signs. Use them. It won't be correct on the test if you don't use them, okay? Won't be 100% correct. So we need f of x plus h. F of x plus h, remember, you take the function wherever x is, you put x plus h. So we've got something squared plus 4, right? And f of x plus h is, I got to plug in x plus h there. This is f of x plus h minus f of x. Our function is x squared plus 4. And that is going to be over h. Okay?
So is that formula on the top right, where it says the fx at x plus h was have a square on the top, or no?
That is right. That is right. Because our original function was x squared plus 4. Wherever the x is, you got to put the x plus h. So that x plus h is squared plus 4 on this first part. So now I'm going to put a smiley face for a couple. Now you can do that if you're going to have to rewrite lim 10 times. Use a smiley face, okay? You're welcome to. You don't have to. You can use lim all the way through if you want to. But now we've got on top x squared plus 2xh plus h squared. Remember that? Plus 4. Now distribute the minus sign. Minus x squared minus 4 over h. Every time, you guys, both of these terms, when I'm subtracting f of x, should go away. This 4, minus 4, and positive 4 are gone. Minus x squared plus x squared are gone. So I've got now the limit again of 2xh plus h squared over h. All right? Now I can factor the h out. Remember, this is saying the limit as h goes to 0. Causes the denominator to be 0. In a second, when we factor that h out and cancel, the problem goes away. That's the goal. So we've got the smiley face again. Take the h out and get 2x plus h over h. Cancel, cancel. Now we're left with, I'm going to rewrite it as lim now. When you get down to the bottom, it's good to remind yourself, what is it you're doing? Of 2x plus h. And now notice, plugging 0 in for h doesn't cause any problems mathematically. So the limit goes away now. LIM goes away, and we plug in 0 wherever h is. That gives us 2x plus 0, which is 2x. Okay? Like I said, there's an x in it. Depending on where you are on the function, the slope is different. If you're at the very bottom of the parabola at x equals 0, what's the slope? 2x. 2 times 0 is 0. At x equals 1, notice what we did the first problem. Notice what, plug in x equals 1 into this slope. What do you get? 2. You get 2. The answer we got right here, the slope was 2. So this is f of f prime of x equals 2x. That is the derivative of this function, f of x, is equal to 2x. Okay? Notice that. Any questions at all on that? Okay, get practice with it, renew it. We did that early on in the semester. Make sure you can do it. It's going to be on the quiz tomorrow, and it's going to be on the test. There'll be a test question for sure, okay? So make sure you're solid. Okay, well, listen. With that, I'm going to go ahead and stop the recording in a minute and let you ask questions, okay? Ask questions about this. You can ask questions about sapling questions you've got or whatever you've got, all right? So I'm going to drop off. Anything more about this? Okay, so I'm going to stop the recording.